we're going to proceed to exercise number 3 in chapter 4. There are two parts to this exercise. Part number 1 is adding support for the modulus operator, and part number 2, adding support for the negative numbers, and also obviously the positive number prefix. As opposed to the previous two exercises where I gave you some of the theory and then some of the thinking behind the exercises, in this one what I'm actually going to do, I'm going to walk you live through how I approach and solve these two problems. So you can see me interact and solve these problems together. So what we're starting off with is essentially the code that we had in the book. And I'm going to go ahead and just work through the problem. So case number 1, the first thing we have to solve, is the modulus operator. So let's go ahead and add support for this here. So we're going to have the case here, and this is our modulus operator. And the modulus operator is similar in terms of its order of precedence, the same way as division and subtraction, which means you can't just do pop pop. The order matters, and you have to do them in a specific order. So op2 gets pop. And then if op2 is not equal to 0, because we can't do the operation there, so I'm going to do pop, the next operation, modulus op2. And else, if it is 0, well, we want to give some kind of an error message. And the error message is going to be, well, you were trying to do a modulus for 0. So modulus of 0. Okay. And then we're going to break. We can see that something's underlined here, so that tells us that there's an error. Expression must have an integral type. Expression must have an integral type. Well, let's go ahead and try and build and see what we get. So I've been using Blaze for Bazel for our build tools. So Bazel build, and we're going to do a little bit of a discussion, more of it in a subsequent video, but here it is. Let's see what's the error. It says, invalid operand to binary expression, double and double. I think what's going on here is that, yeah, so this is only really defined an integer. So we're going to have to convert this to an integer type. So let's go ahead and do that. That means we need a mod operator 2 here. And now let's go ahead and add this here. So mod operator 2. To be safe, we're going to go ahead and cast this operation here. Let's test this as well here. And just to be safe, we're going to cast this one and cast and then perform the operation here. And let's see what we get. Okay, the squiggly lines are out. That means that things are working. Let's go ahead and build. Okay, things are built, and let's go ahead and run. And let's just test it out. So let's say 4, 9 should give us this. What if we reverse it? 9, 4 modulus. Maybe we'll do 17, 23 modulus. That should give us 17. If we reverse it, should be something more exciting. Okay, so it seems to be working. So let's move on to the next part. The next part is adding support for negative numbers. Okay, so let's come into here and see what's going on here. So this is our logic for the parsing out the digits. One of the things that you don't have in the book is that it doesn't have any comments really, but we can go ahead and add comments to make it a little bit more readable for us here. So let's skip white space, skip leading white space really. And here's the first interesting bit here. So if it's not a digit and it's not the period, we want to return it. So it's going to return things like negative, plus, minus, and whatever. But we actually don't want to do that. We actually want to also handle this case, and C does not equal positive sign. So that we want to have special handling for these so we don't lose them. But that means that if it is negative or positive, we're potentially going to skip over something. So I think what we need is another variable here really quick just to keep track of the sign. And then we'll do it like this. If C is equal to negative or C is equal to positive, then we're going to go ahead and say sign gets this value of C. And just to be safe, we're going to initialize it to 0. That's sort of the nice way of doing it. And if it's a digit, or we can actually say sign is bigger than 0 here, That means we got something, we have a sine value. Then we'll go ahead and continue this parsing. So that's all fine. And then if we have a period here, that's all fine. But now we have to do some special handling here. So if I is equal to 1 and sine is not equal to 0, well, that tells us that we only parsed out the sine value. So what we want to do then, we want to actually get, because we probably would have got one thing too many, I get something like the new line potentially, and then we want to return sine, right? Because we would have potentially would have parsed it here. Here we would have gotten one character too many. This would have been the new line. This would have failed then, and then we would have not made this whole thing work, right? So we want to put whatever we parsed here that was not a digit back using this here, and then here's our sine value. We want to return that. Okay, let's make sure it all builds. Okay, great, so no errors there. Let's go ahead and run. So let's do some basic things. Let's do 23, 34 plus. Okay, so that looks right. What about negative 23, 34 plus? That looks right. What about negative 23, 34 minus? Okay, that looks right. Right, so what about negative 23 minus 34 minus? Right, so that's the addition. What if we do multiplication of negative numbers? So negative 11, negative 4 times. Okay, that works. 4, negative 12 divide. Okay, that seems to work. Let's do maybe a modulus of negative numbers. So negative 4, 3 modulus. What's that going to give us? That's negative 1. What about negative 4, negative 3 modulus? That's also negative 1. Okay, I'm not going to argue. I don't know the arithmetics behind negative modulus. What about floating point? So let's really be tricky here for a moment and say negative 0.123 and then positive 0.23, and then we'll subtract this one. Aha, looks like it's working. So let's do one more. Positive 0.345, whatever, and then minus 0.23 plus, and probably the multiplication is going to work all right. Yep, looks like it's all working. It looks like it's giving us the right value, so that seems to be working fine now. And let's just add a few more comments here. So just to make sure we can read this. So this is going to essentially saying if we got negative or positive, track it as a sign. And then over here, let's go ahead and make a comment here just to make sure we can read it easily. If this is if this is not a digit or a decimal point or negative or positive, then return what we parsed. Likely. Okay, so I think this gives us a little bit more things there, and then let's just add one more comment here because I think this is a little bit of a tricky piece here. So if we only parsed one character and it is a sign character, then fall back to what was there before, and then fall back to returning the sign value. Okay, so I think that's about it, and this should now be good enough, and it's working. We tested it, and this is how I approach solving one of these problems beginning to end. In the next one, I'm going to discuss bazel a little bit more depth because we're going to need it for future exercises, exercise 4, 5, and 6, because they will build in exercise 3, and it would be nice to reuse code. And a build tool like Bazel is going to help us out. We'll maybe also touch base on a little bit of testing. And I'm also going to touch base in a future video on how to use the Linux and OS X manual to look up for different functions and functionality within the operating system. Thank you. If you have any questions, feel free to ask them in the comments or anywhere else you'd like.